Hello and welcome to this NPTEL on fundamental of electric drives. Electric drives, it will deal with control of various types of electric motors using primarily solid state devices. So, let us begin with this course. Electric drives are used in day to day application, this is also used in industry. Whenever there is a motor, we use electric drives. For example, in our household application, we have an air conditioner which uses electric drives. So, some of the examples of electric drives are the following: air conditioners, washing machines, these are used in household applications. And we have applications for example, electric cars, electric vehicles, locomotives or trains, and also we have industrial applications. Say for example, these electric drives can be used in very high power applications, for example, in steel rolling mill, textile mills, and any industry requiring motion control. So, these are actually a few typical applications. So, electric drives are used in almost all aspects of our day to day life. Whenever there is a motion, we use electric drives. It can be rotational motion, it can be a translational motion. Whenever there is a motion, we use electric drives. Now, what are the various components of electric drives? So, we will now discuss about various components of a typical electric drive, or we can say that block diagram of a typical electric drives. Now, what is this? The block diagram of a typical electric drives. Now, at the center of this drive is an electric motor. There has to be a motor which will rotate, and the motor has to be controlled and has to be supplied from a power supply. So, first of all, we have an electric motor. So, we have a motor here. This is the heart of the drive, and this motor is supplied from what is called a power modulator. This feeds this motor, and the power modulator gets the power from a power supply. And then the motor feeds a load. So, we have the load here, which is connected to the motor by mechanical coupling. It is a mechanical load which is being driven by the motor. And now we have to control it. It means we have to control the speed and torque of the motor. So, there has to be a closed loop feedback. So, we will now see the closed loop feedback in the drive system. So, we sense the various parameters here, and then what we have here is a sensing unit. And then we have the control unit. And the control unit controls the power modulator. It means the power supply can be fixed, but the motor speed may have to be changed, motor torque may have to be changed. Think of a situation, you are going in an electric vehicle, maybe an electric car or an electric bus. The speed of the car has to be controlled. Now, how do we control the speed of an electric car? That control can be achieved by the power modulator. The power supply can be fixed, it could be DC or AC, but the power modulator has to match the power supply with the motor's requirement. So, the power supply could be a AC power supply or it could be a DC power supply, and motor similarly could be an AC motor or it could be a DC motor or it could be any special motor, and the load can be any mechanical load. Now, when we combine all this component, we call it an electric drive. Now, only motor is not an electric drive. When we combine the motor with the load, with the power modulator, with the source, and there is a closed loop feedback, this is called an electric drive. Now, let us try to understand each component of this block diagram. We will first talk about the electric motor. Now, when we talk about the motor, parts of electric drives, the first part is electrical motors. Now, these electrical motors can be of various types. For example, you can have DC motor, you can have AC motor, you can have some special motors. So, let us start with a simple DC motor. So, when we talk about DC motors, we can have shunt motors or separately excited motor. We can have series motors, we can have compound motors, and we can also have permanent magnet motor. Similarly, when we talk about AC motors, we have few categories here. We can have induction motors, and induction motor can also have some classifications. We can have squirrel cage induction motor, we can have slip ring or wound rotor induction motor, or we can have linear induction motor as well. So, these are the classification of induction motors, which are very widely used in industry. Now, another type of AC motors are called synchronous motors. The synchronous motors are only limited for very high power applications. So, what are the various types of synchronous motors? So, we have synchronous motor. Similarly, we can have wound field. So, in this case the field will have the winding, and field is excited by means of a DC supply. So, in a synchronous motor, field is excited by a DC current to produce a DC flux, and that produces the magnetizing flux in the motor. Now, in some electric vehicle application, we also use permanent magnet synchronous motor. In that case, the wound field is not present, but instead of a wound field, we have set a permanent magnets in the rotor, which gives the excitation for the motor. So, these are called permanent magnet motors. Permanent magnet synchronous motors. Now, apart from this, the DC motors and AC motors, we have some special motors. For example, a class of motors are called brushless DC motors. The DC motors usually have brass. Now, the brass and the commutator require lot of maintenance, because the brass repeatedly wears out, they have to be replaced, and even they also create sparking. Now, to have a maintenance free motor, we can have brushless DC motors, where there is no mechanical commutator and brass, and the commutation is basically achieved by an electronic inverter, and inverter is an integral part of the motor. In brushless DC motor, we do not have any brass and commutator. And then we have stepper motors. Which are used for robotics and control application, which do not require any closed loop feedback, which are used only for control applications. And then we have type of motor which is called a switched reluctance motor. And these are used for space application, because the rotor weight is very light, we have very less inertia, and this can be accelerated and decelerated quite easily. So, these are the classification of electric motors. Now, we will see the next component, that is the power modulator. The power modulators match the requirement of the motor with the power supply. Now, the power supply can be AC or it can be DC, and the power modulator convert one form of electric energy to some other form of electric energy. So, we start with first DC to DC converters. So, in power modulators, we have DC to DC converters, and these are called choppers. And we can either have a step up chopper, or we can have step down chopper, or we can have both step up and step down chopper combined together. This converts DC to DC. Now, we have a type of converters which convert AC to DC. What are these converters? These converters can be simply diode rectifiers, which just are uncontrolled rectifiers which convert AC to rectified DC. And we have some converters which change AC to a variable DC. They are called controlled rectifiers. So, we can have half control rectifiers, we can also have full control rectifiers, we can have transformers with tap changers, plus diode rectifier, we can also have a diode rectifier, plus DC to DC converters or choppers. So, these are the various types of AC to DC converters. It means if we have AC supply, suppose we have single phase 230 volt AC, but our motor is a DC motor. So, we have to use the power modulator which is a AC to DC converter. Either it is an uncontrolled rectifier or it is a half control or full control rectifier and so on. Now, we have again another class of power modulator which converts DC to AC. We have DC supply, but the motor is an AC motor. Say for example, for solar applications our energy is DC, but we have to drive an induction motor. In that case we have to use DC to AC converters which are known as inverters. So, we have DC to AC converters, they are also known as inverters. And we have two types of inverter, one is called a voltage source inverter or we abbreviate this as VSI, and also we have current source inverters. And we call this as a CSI. Now, we have the last type of power modulator which converts AC to AC. We have AC supply which is fixed voltage and fixed frequency, but we need maybe a variable voltage, a variable frequency or variable voltage fixed frequency, and in that case we use AC to AC converters. So, AC to AC converters we have AC voltage regulator, which converts fixed frequency fixed voltage to a fixed frequency variable voltage. Those are called AC voltage regulator. And then we also have AC to AC converters which are called cyclo converters. The cyclo converters converts fixed AC, fixed voltage, fixed frequency to variable voltage, variable frequency. Now, these are the power modulators which are used for controlling electric motors. So, we have discussed about the electric motor, we have also discussed about power modulator. We have another important component of an electric drive which is the power supply. The power supplies are of various types, they can be AC, they can be DC, they can be single phase, 3 phase of variable of various voltages. So, we will very briefly discuss about the power supply. So, when we talk about the power supplies, we mainly use AC power supply very widely, because the AC power supply can be easily stepped up, can be transmitted to a long distance, stepped down can also be used. So, the AC power supplies can be available at various voltage and frequency. So, we have it can be single phase for domestic application, we can have 3 phase power supplies, and in our country it is 50 hertz, it could also be 60 hertz. And when the motors are low and medium power, they use primarily 400 volt 3 phase 50 hertz, this is in India, or 230 volt single phase 50 hertz. So, this is used for low and medium power motors. Now, when the motors are high power, we use higher voltage power supply. For high power drives, we use higher voltages, and those are 3.3 kV, it could be 6.6 kV, it could be 11 kV. So, we have the motors which can be supplied from this high power high voltage supplies, because the power itself requirement is very large. So, we have to use higher voltage power supplies. And then for aircraft application, when we talk about space application or aircraft application, the frequency is not 50 hertz. For aircraft application, we use 400 hertz power supply. So, for aircraft AC power supply, we use 400 hertz frequency, because when the frequency is high, the magnetic component weight can be reduced, the volume can be reduced, and that is an added advantage to aircraft and space application. Now, for electric traction, primarily for locomotive, for the main line trains, we go for 25 kV, 50 hertz and single phase, and this is for our country. So, these are the various AC power supplies that we have. So, the AC power supply can be for low power, can be for medium power, can be for high power. So, whenever we have an AC power supply, we have to use suitable power modulator to match with the requirement of the motor and load. When we talk about DC power supply, the DC power supplies are very commonly supplied from batteries. It can be 48 volt, it can be 100 volt, it can be any given voltage, and the power source is primarily from batteries. And nowadays, with the availability of solar power, the DC voltage can also be obtained from solar powers. So, for the DC power supplies, we can use the solar power, of suitable voltage and power, or we can have battery of suitable voltage and ampere hour, these to meet the load requirement. Okay. So, So, these are the power supplies that we have. Now, when we have all these power supplies, we have to choose one of the power supplies for a given applications and use a suitable power modulator to match with the motor. Now, when we talk about electric drives, now what are the advantages of electric drives? We will briefly discuss about the advantages of electric drives. Now, we are controlling an electric motor from a power converter or from a power modulator. Now, the advantages are many. Some of the advantages are it does not require any gear. First of all, whenever we have any vehicle, we need to have a gear for changing the speed, but an electric vehicle or an electric locomotive does not require any gear. That is a very big advantage. So, this runs without any gears. So, we will be discussing about the advantages of electric drives. The number one advantage is absence of mechanical gear, absence of mechanical gear. Why? Because speed is changed electrically, speed is changed electrically. And then we have some other advantage. For example, we have high efficiency. The power converters, the efficiency is very high. So, the overall efficiency of the drive is also very high. And then we have non-polluting. The electric vehicles, they do not emit any effluent, there is no harmful gas emission, at least from the vehicle. So, the vehicles are quieter in operation, they run mostly almost quietly, also they do not emit any harmful substance. And then we have 4 quadrant operation. Which means we can operate in motoring, braking and with speed reversal, with reversible speed. Now, we have wide range of torque, speed and power. So, when we talk about an electric drives, we can have a very wide range of power application. Think of a computer fan. The computer fan is also an electric drive, it is only a few watt. Mixer grinder, that is a few hundreds of watts. Air conditioner, that is few thousands of watts. When we talk about industrial drives, they are in hundreds of kilowatts. Traction application, that is in megawatt. So, starting from very low power drive, we can also scale it up to high power very easily by only changing the rating of the power converters and the rating of the power supply. So, we conclude the first lecture today and we will be discussing more things in the next lecture.